sum of the numbers is equal to 0, then 3ax² plus 2bx plus c equal to 0. This is the quadratic equation in x. So it has option A, at least one root in closed interval 0, 1. Option B, at least one root in closed interval -1 to 1. And then at least one root in closed interval 0, 2, or none of these. So we have to check this. Before starting with the solution, let's recall the Rolle's theorem here. If a function f is continuous on closed interval ab and differentiable on open interval ab such that f of a is equal to f of b, that is the value of the function at x equal to a and the value of the function at x equal to b. If these two are equal, then f dash x equal to 0, that is the first derivative of the function is 0 for some alpha belonging to the closed interval ab. So we are going to use this Rolle's theorem in this solution, which is very helpful. Now the given equation is 3ax² plus 2bx plus c equal to 0 and sum of the numbers which are belonging to the set of real numbers is equal to 0. If you notice over here that this 3ax² plus 2bx plus c equal to 0, this is the derivative of ax cube plus bx squared plus cx. If you take the derivative of this fx, you will get 3ax² plus 2bx plus c equal to 0, this equation, right? And please notice that because this is your polynomial function, so every polynomial function is continuous. And also it is derivable at all the points belonging to the real numbers. So now I'm going to use the Rolle's theorem over here for this function. So f is continuous and derivable on set of real numbers, right? Then next condition for the Rolle's theorem should be that f of a should be equal to f of b for the interval ab. For the third condition, if I check that f of 0, what is f of 0? If you put 0 over here at x equal to 0, we get a into 0 cube plus b into 0 square plus c into 0. That gives us 0. And what is f of 1? Putting 1 over here, we get a into 1 cube plus b into 1 square plus c into 1. That gives us a plus b plus c. And from the given condition, this sum of the numbers is equal to 0. So this sum is also equal to 0. So from these two, what we are saying that f of 0 is equal to f of 1. So we have searched an interval 0, 1. Right? Now for all these conditions, therefore, by Rolle's theorem, there exists at least one real number, let's say alpha, belonging to this closed interval 0, 1, because we are getting f of 0 equal to f of 1. At these two values, we are getting the functions to be equal. So we are taking the interval 0, 1, the closed interval, such that f dash x is equal to 0. So thus 3ax² plus 2bx plus c equal to 0 has at least one root in closed interval 0, 1, right? Which means we are getting the first option, at least one root in closed interval 0, 1. Let's check the other options also. Now this is your 0, 1 closed interval. If you notice that this interval is also the subset of -1 to 1 closed interval. This 0, 1 is a subset of -1 and 1 closed interval, which means if the root is belonging to closed interval 0, 1, that means this root also belongs to the closed interval -1 and 1, right? So second option is also correct. Let's check for the third option, that is this root also belonging to 0, 2 or not? Yes. Why? Because this closed interval 0, 1 is also the subset of 0, 2. Right? So this closed interval 0, 1 is also the subset of the closed interval 0, 2. So that one root belonging to 0, 1 closed interval is also belonging to the closed interval 0, 2. Yes. So the third option is also correct. So the answer option A, option B and option C all are correct.